Alright, so anyone doing level 3 maths, okay, this is what we're doing now is called the binomial theory. Binomial theory, okay? Now, if you go to Blackboard, you go to my lecture notes, the deriving this theory is there and it's lovely and everything, so just take the time to read it. But I'm going to put it into context here, okay? So, assume you have a cylinder, okay? The volume of a cylinder, assume it to be pi r squared h. This is not an assumption, this is the actual volume equation. Okay, now I'm going to say that the cylinder is reduced by its radius. I'm going to reduce it by 4%. Okay, I'm going to increase its height by 2%. Okay, and you're told to determine the change in volume. Okay, easy, easy. So volume of the cylinder, this is the equation, and these are the conditions I'm setting. Okay, so what do I have? Okay, so if we think about it, alright, the radius, I said the radius was going to decrease by 4%. Okay, now if we take this in percentages, alright, if you turn 4% as a decimal, that's 0.04. Okay, now we know that the maximum percentage you can have is 100%, okay, which just means 1. Okay, now the original radius size was r. Alright, that's the original radius. But we're going to decrease it by 4%. Okay, minus 0.04r. Okay, I've translated the question into mathematical concepts. Okay, and the same goes for the height. Okay, the height, I said the height was going to increase by 2%. Okay, so, well, 2% as a decimal point is 0.02. Okay, and if it increases, oops, I'll rub that out. Okay, fair. Now, if I have 100%, that will give me 1. Okay, 100 divided by 100 is just 1. 2 divided by 100 is 0.2. So that was the original height. Okay, and I did the mistake again. Sorry, folks. That's a h. Okay, so my original equation, which was pi r squared h. Now that's the original. Now it's transformed into more of something like r, the original, minus what we determined to be the minus 0.04 r again, squared, because it was squared. Okay, and these are all multiplied against each other. The original height, add 0.02 off the height. Okay. Okay, now if we do this, so just doing this part, alright, that is r minus 0.04 r, r again minus 0.04 r, times h plus 0.02 h. Okay, and what we have is, well, that's r squared minus 0.08 r squared again plus 0.0016 r squared again times, well, that didn't really change. Okay, now this part's the easiest part. Okay, pi times, alright, we can factor each of these has the r, right? This has a term with the r. Remember, this the coefficient of this is 1. This is r squared, that's r squared, that's r squared. So we can take r as the common factor. We can take r squared out as the common factor. Okay, we can leave the numbers back in. So that's 1 minus 0.08 plus, yeah, because them two add together. 0.0016. Close that again. And we can do the same over here. Over here we'll have h in the background, and we can take 1 because that's 1 plus 0.02. Okay, and what we're going to have is pi times 0.9216 r squared times 1.02 h. Okay, now let me take this to the next page. Oh, you know what, I'm not going to do that. I'll just rub off this top part. Okay, and I'll rewrite it in blue. Okay, so now I have pi times 0.9216 r squared times 1.02 h. Okay, because now we're multiplying, alright, I can just multiply these numbers simply together, and I can get one number, pi r squared h. Okay, and that number in this case is 0.94. Okay, 0.94 pi r squared h. So this means that the original equation for the volume, okay, the original equation was pi r squared h. Okay, now this equation had no corrections whatsoever. Now, when I used the corrections, the r was decreased by 4% and the height was increased by 2%. These corrections produce an equation that's this, all right, which is 0.94, okay, of the original equation. That will account for the changes in the radius and the height. Your volume will be accounted. Now the volume will have an accurate illustration, okay, according to those changes, all right? And that's all you would have to do for that. Cool. Oops.